Hello, in this lecture we will find the area of triangle ABC in two different ways. In the drawing we have triangle ABC with side AB that equals to 8 units, side AC of triangle ABC equals to 14 units, angle ABC equals to 2x and angle ACB equals to x. Angle ABC equals to 2x degrees and angle ACB equals to x degrees. And we want to find out the area of this triangle, triangle ABC. Okay, so first of all, we will draw a line segment such as the angle this point between the line segment, the touching point between the line segment and side BC will be defined as point D, and we drew this line segment in such a way that angle ADB will be equal to 2x. Okay, so again we draw line segment AD in such a way that angle ADB equals to 2x. So actually triangle ADB, we have two angles that are equal to each other. Angle ADB equals to angle ABD, and therefore triangle ADB is an isosceles triangle, and therefore AB equals to AD, and AB equals to 8 units, so AD will be equal also to 8 units. And actually we have a theorem, a rule number 1, that states that if we have any triangle ABC, okay, so if we have triangle ABC and this angle is angle alpha, this angle is angle beta, then the exterior angle ACL, this angle will be also equal to alpha plus beta. Okay, it is true in any triangle. If this angle is alpha and this angle is beta, then the exterior angle ACL will be equal to alpha plus beta. Actually, it is very simple to prove it because the sum of the angles in any triangle equals to 180 degrees. So actually this angle ACB will be equal to 180 degrees minus the sum of those angles, minus alpha plus beta. Okay, and we know that the sum of the angles along a straight line equals to 180 degrees. So actually, if we define angle ACL as x, then x plus 180 degrees minus alpha plus beta must be equal to 180 degrees, because of the fact that the sum of the angles along a straight line, on the upper side of a straight line at a certain point, is equal to 180 degrees. So this angle plus this angle must be equal to 180 degrees. So if this angle is x, then x plus this angle, that is 180 degrees minus alpha plus beta, must be equal to 180 degrees. So here we have 180 degrees on both sides of the equation. So 180 degrees cancelled. So here we will get that x, angle x, equals to alpha plus beta. Okay, so we proved that this angle equals to alpha plus beta. So in our triangle, we can implement this rule in our triangle, and if this angle is actually angle DAC, angle DAC plus angle X must be equal to angle ADB, that is actually 2x actually we got this equality according to the rule that states that angle DAC plus angle X must be equal to the exterior angle, angle ADB. Okay, so angle DAC plus angle X must be equal to this angle, that is 2x. Okay, angle DAC plus angle X must be equal to this angle, that is actually equals to 2x. So here we can subtract x from both sides of the equation, and we will get that angle DAC equals to x. Angle DAC equals to x. So we can write here that this angle equals to x, but we have here triangle with two angles that are equal to each other. In triangle ADC, angle DAC equals to angle DCA. Therefore, triangle ADC is an isosceles triangle. That is to say, AD equals to DC. AD equals to DC, but AD equals to 8 units. So DC must be also equal to 8 units. Okay, again, triangle, in triangle ADC, we have angle DAC that equals to angle DCA. Those two angles are equal to each other. They are equal to x. Therefore, triangle ADC is an isosceles triangle, That is to say, AD equals to DC. But AD equals to 8 units, so DC also must be equal to 8 units because AD equals to DC. Okay, so in the next step, we will draw a perpendicular from point A to side BC of triangle ABC. And we will call to the tangent point between the perpendicular and side BC of the triangle point E. Okay, actually this is point E according to our definition. This is a right angle and this is also a right angle. We will define AE as edge in triangle AEB. Triangle AEB is a right triangle. Again, triangle AEB is a right triangle because this is a right angle, this is also a right angle. Therefore, we can implement the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. But before that, we have a second rule that states we know that triangle ABD is an isosceles triangle because AB equals to AD. And in any triangle, in any isosceles triangle, if you have isosceles triangle, if triangle ABC is an isosceles triangle, that is to say AB equals to AC, then if you draw a perpendicular from point A to this point, point E, we know that triangle ABC is isosceles triangle, that is to say AC equals to AB. If you draw a perpendicular from point E to side BC of the isosceles triangle, this angle is 90 degrees, this angle is 90 degrees, then BE will be equal to EC. Okay, BE will be equal to EC. So, whenever you draw a perpendicular in isosceles triangle, then that perpendicular creates two equal sides, that is to say BE equals to EC. BE equals to EC. So, in our drawing, we have a triangle ABC, and we know that triangle ABD is an isosceles triangle because AD equals to AB, therefore triangle ABD is an isosceles triangle, and we draw perpendicular from point A, therefore ED equals to BE. So in the isosceles triangle, triangle ABD is is an isosceles triangle. Okay, triangle ABD is an isosceles triangle because AB equals to AD. Therefore, because of the fact that we draw a perpendicular from point A to BD, then according to the rule that I mentioned before 2 minutes, BE must be equal to ED. BE must be equal to ED because the perpendicular from point A creates two equal sides. That is to say, BE equals to ED. Okay, BE equals to ED. And if we define BE as A, if BE equals to A, then ED that equals to BE will be also equal to A. Okay? So, in the right triangle, triangle AEB is a right triangle because angle AEB is a right angle. So in the right triangle, triangle AEB, in triangle AEB, we can implement the Pythagorean theorem. AB square equals to BE square plus AE square. Again, in the right triangle, triangle AEB, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to BE square plus AE square. And what is the value of AE? AE equals to 8 units, so AB equals to 8 units, so AB square is 64 equals to BE square. BE equals to A, so BE square is A square. That is equation number 1. A square plus AE square. AE equals to H, so AE square is H square. Okay, so equation number 1 states that 64 equals to A square plus H square. Here we will subtract A square from this equality, and we will get that H square equals to 64 minus A square. Okay, H square equals to 64 minus A square. Okay, and actually triangle AEC is a right triangle. Again, triangle AEC is a right triangle because angle AEC equals to 90 degrees. Therefore, triangle AEC is a right triangle. Okay, triangle AEC is a right triangle. Therefore, according to the Pythagorean theorem, the square of the hypotenuse, that is 14 square. This will be our second equation. 14 square equals to AE square is AE equals to H, so it equals to H square plus EC square. And EC equals to ED plus DC. ED equals to A and DC equals to 8, so EC equals to A plus 8 square. Again, in the right triangle AEC, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse, that is 14 square, equals to the sum of the squares of the perpendiculars, equals to h square plus a plus 8 square. Okay, 14 square equals to h square plus a plus 8 square. But in equation number 1, we found out that h square equals to 64 minus a square, so we can substitute h square in equation number 2 by h square, that equals to 64 minus a square from equation number 1, and we will get that 14 square equals to h square, but according to equation number 1, h square equals to 64 minus a square plus a plus 8 square. We will open the brackets. A plus 8 square equals to a square plus 64 plus 16 times a. Okay, so that is what we got in equation number 2. Here we have a square minus a square plus a square is 0, so a square is cancelled. And 64 plus 64 is 128, and 4 square is 196. So I write it down. Fourteen square is 196, equals to 164 plus 64 is 128 plus 16a. Okay, here we will subtract 128 from this equality, from equation number 2, and we will get that 68 equals to 16a. Okay, we found out that 68 equals to 60a. Here we will divide this equality, equation number 2, by 16 in order to get the value of a. So a will be equal to 68 over 16. That is actually, we can divide the numerator and the denominator by 4, and we will get that 68 by 4 is 17. 16 over 4 is 4, so a equals to 17 over 4 is 4 and quarter. We found out the value of a. A equals to 4¼ okay, the value of A, B, E equals to A and ED also equals to A. They are equal to 4¼ units, and from equation number 1 we know that H squared equals to 64 minus A squared. So according to equation number 1, H squared equals to 64 minus A squared. That is equation number 1. Here we will take a root out of this equality and we will get that H equals to 64 minus A squared. The root of 64 minus A squared, but we've already found out that A equals to 4¼ so we can substitute A squared by 4¼ so H will be equal to the root of 64 minus 4.4¼ square. If we do 4¼ square, 4¼ if we square 4¼ we will get that equals to 18.0625. So H equals to the root of 64 minus 18.0625. Equals to the root of 45.9375. So H equals to 6.78. So H equals to 6.78 and A equals to 4.25 units. Okay, we found out that H equals to 6.78 units and A equals to 4.25 units, and actually the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area, the formula for the area of any triangle equals to the base of the triangle times the height to the base over 2 Okay, this is the formula for the area of any triangle. The base times the height to the base over 2 is the area of any triangle. So the area of our triangle ABC, A is the abbreviation for area, will be equal to the base, that is BC, times the height to the base. The height must create 90 degrees with the base, and AE indeed creates 90 degrees with the base BC. Therefore, AE that equals to edge is the height of triangle ABC. So it is the base BC times the height, that is h, over 2. Okay, so the area of triangle ABC equals to the base BC times the height to the base, that is h, over 2. What is the value of BC? The value of BC equals to A plus 8. That is to say, BC equals to 2A plus 8. What is the value of h? We have already found out that h equals to 6.78 units all over 2. So the area of triangle ABC equals to 2A plus 8 times 6.78 over 2. We have already found out that A equals to 4.25 units. So we substitute A by 4.25. 2 times 4.25 is 8.5. So I write it down. And okay, it is 8.5 plus 8 times 6.78 over 2. Okay. So the area of triangle ABC equals to 8.5 plus 8, that is 16.5, times 6.78 over 2. So the area of triangle ABC equals to 16.5 times 6.78 over 2. Okay. The area of this triangle ABC equals to 16.5 times 6.78 over 2. So the area of triangle ABC will be equal to 55.93. 55.935 square units. Okay, so the area of triangle ABC equals to 55.935 square units. Okay, the area of this triangle ABC equals to 55.935 square units. Okay, so in the next step I will show you another way, second method, to find out the area of this triangle ABC. Okay, we know that the sum of the angles in any triangle equals to 180 degrees, so I will define this angle as angle A. So angle A plus x plus 2x must be equal to 180 degrees. Okay, so in any triangle the sum of its angles is equal to 180 degrees, so angle A plus angle x plus angle 2x must be equal to 180 degrees. So here we'll find out that angle A plus x plus 2x is 3x equals to 180 degrees. So angle A equals to, we'll subtract 3x from this equality, and we will get that angle A equals to 180 degrees minus 3x. Okay, we actually found out the value of angle A. Angle A equals to 180 degrees minus 3x. Okay, we actually have a rule that states that the area of any triangle, if we have triangle ABC this triangle ABC, if we know that side AB equals to A units, side AC equals to B units in size, and the angle between side AB and side AC is theta, then the area of this triangle ABC, A is the abbreviation for area of triangle ABC will be equal to A times B times sinus theta. The area of this triangle ABC equals to A times B times sinus theta. So we can implement this rule in our triangle ABC according to the rule that I mentioned. Now the area of this triangle ABC, A is abbreviation for area, the area of this triangle, triangle ABC, will be equal to AB times AC times sinus 180 degrees minus 3x. Okay, according to the formula that I mentioned 1 minute ago, the area of our triangle, triangle ABC, equals to AB times AC times sinus 180 degrees minus 3x. But what is the value of AB? AB equals to 8 units and AC equals to 14 units. And okay, so here we actually I made a mistake about the area of the triangle. The area of this triangle, triangle ABC, equals to A times B times sinus theta over 2. Okay, I forgot to divide it by 2. Again, the area of this triangle, triangle ABC, equals to A times B times sinus theta over 2. Therefore, the area of this triangle will be equal to AB times AC times sinus 180 degrees minus 3x over 2. Okay, we must divide this by 2. So AB equals to 8 units, AC equals to 14 units, so it is 8 times 14 times sinus of 180 degrees minus 3x over 2. So the area of triangle ABC equals to 8 times 14 times sinus 180 degrees over 2. We have trigonometric identity that states that sinus of 180 degrees minus theta equals to sinus theta. So according to this trigonometric identity that states that sinus 180 degrees minus theta equals to sinus theta, sinus 180 degrees minus 3x will be equal to sinus 3x. So I'll write it down. So the area of triangle ABC will be equal, here 14 over 2 is 7, and 7 times 8 is 56, and here sinus of 180 degrees minus 3x according to this trigonometric identity equals to sinus 3x. Okay, so in total we got that the area of triangle ABC equals to 56 times sinus 3x. We have the second trigonometric identity that states that sinus 3x equals to 3 sinus x minus 4 sinus Okay, we have this trigonometric identity that states that sinus 3x equals to 3 sinus x minus 4 sinus x to the power of 3. Okay, so according to this trigonometric identity, we can write down that sinus the area of triangle ABC equals to (56) times sinus x, but according to this trigonometric identity, sinus x equals to 3 sinus x minus 3 sinus x to the power of 3. Okay, so here we can take a common factor sinus x out of this equality. Again, we can take a common factor sinus x out of this expression, and we will get that the area of triangle ABC equals to 56 times 3 sinus x we took sinus x as a common factor of this expression, and inside the brackets we will have here 3 minus 4 sinus x squared. Okay, so we found out that the area of triangle ABC equals to 56 times sinus x, 3 minus sinus x squared. Okay, but we have already found out the value of we know that we have the following trigonometric identity that states that sinus x squared plus cosinus x squared equals to 1. Here we'll subtract sinus x squared from this equality, and we will get that cosinus x squared equals to 1 minus sinus x squared. Here we will take a root out of this equality, and we will get that cosinus x equals to the root of 1 minus sinus x squared we actually must use here the law of sines. According to the law of sines, in any triangle ABC, if we know that the size of side AB is A units and the size of side BC is B units and the size of side AC is C units, that is actually the law of sines. Okay, that is the law of sines. According to the law of sines, and we know that the angle between BC and AC is alpha, and the angle between BC and AB this is angle gamma, and the angle between AB and AC is beta. Then according to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. And it is true in any triangle. Again, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. So we can implement the law of sines in our triangle ABC. So according to the law of sines, 8 over sinus x will be equal to 14 over sinus 2x. Okay, so in our triangle ABC, this equality is true according to the law of sines, that 8 over sinus x equals to 14 over sinus 2x. Okay, but we know that sinus 2x equals to 2 sinus x cosinus x. So I write it down. 8 over sinus x equals to 14 over sinus x equals to 2 sinus x cosinus x. Okay, we got this equality according to the law of sines. Here we can cancel sinus x in the denominator because we have sinus x in both sides of the equation, so we can cancel sinus x, and we will get that 8 equals to 14 over 2 is 7 over cosinus x. So here we will get that cosinus x equals to 7 over 8. Okay, we got that cosinus x equals to 7 over 8, and we have already found out that cosinus x equals to the root of sinus x, again cosinus x equals to 7 over 8 . We found out that cosinus x equals to 7 over 8, and we have the trigonometric identity that states that sinus x squared plus cosinus x squared equals to 1. So actually sinus x squared equals to 1 if we subtract cosinus x squared from this equality. We'll get that it equals to 1 minus cosinus x squared. Here we'll take a root out of this equality, and we will get that sinus x equals to the root of 1 minus cosinus x squared. Okay, but we have already found out that cosinus x equals to 7 over 8. If cosinus x equals to 7 over 8, then cosinus x squared will be equal to 49 over 64. We will square both sides of this equality, and we will get that cosinus x squared equals to 49 over 64. Okay, so cosinus x squared equals to 49 over 64. So we can substitute cosinus x squared from this equality by 49 over 64, because cosinus x squared equals to 49 over 64, and we will get that sinus x equals to the root of 1 minus, instead of cosinus x squared, we will write down 49 minus 64. So we got that sinus x equals to the root of 1 minus 49 over 64. Okay, and here we will instead of 1 we will write down 64 over 64, so it will be, or we will take a common factor 64 out of this equality. 1 is 64 over 64, so it is 64 minus 49 over 64. Okay, sinus x equals to 64 minus 49 over 64. 64 minus 49 is 15. So we found out that sinus x equals to 15, the root of 15 over 64, or sinus x equals to the root of 15, and the root of 64 is 8. So we found out that sinus x equals to the root of 15 over 8, and we actually found that the area of triangle ABC equals to 56 times sinus x times 3 minus 3 sinus x squared. Okay, so I will copy again what we have already found out, that the area of triangle ABC equals to 56 times sinus x, and in the brackets we have 3 minus 4 sinus x squared. Okay, so we found out that the area of triangle ABC equals to 56 times sinus x. In the brackets we have 3 minus 4 sinus x squared. And we know that sinus x equals to the root of 15 over 8. Sinus x equals to the root of 15 over 8. Okay, so here we can substitute sinus x by root 15 over 8, and sinus x squared will be equal to 15 over 64. Okay, so the area of triangle ABC will be equal to 56 times sinus x equals to root 15 over 8, (3 minus 4 sinus x squared equals, here if sinus x equals to root 15 over 8, then sinus x squared will be equal to 15 over 64. Okay, we substitute sinus x squared by 15 over 64. So in total we got that the area of triangle ABC equals to 56 times root 15 over 8. In the brackets we have 3 minus 4 times 15 over 64 here 56 over 8 is 7, and here we can divide, we can cancel 4, because 64 over 4 is 16. So the area of triangle ABC will be equal to 7 times root 15, because 56 over 8 is 7. So here we will cancel 4. 64 over 4 is 16. Okay, so in total we got that the area of triangle ABC equals to 7 times root 15. In the brackets we have 3 minus 15 over 16. Here, instead of 3, we can write 48 over 16 equals to 3. So actually we take a common factor 16 out of this equality, and the area of triangle ABC will be equal to 7 times root 15 times 48 minus 15 over 16. Okay, the area of triangle ABC equals to 7 times root 15. 48 minus 15 is 33. So 33, the area of triangle ABC will be equal to 7 times root 15 times 33 over 16. Okay. The area of triangle ABC equals to 7 times root 15 times 33 over 16. So 7 times 33 is 231. So I write it down. So the area of triangle ABC equals to root 15 times 331 over 16. Again, the area of triangle ABC equals to root 15 times 231 over 16 units, or square units. Okay, so now I will summarize the lecture. Actually, we found out the area of triangle ABC in two different ways. The area of this triangle in two different ways. According to the first method, we draw line segment AD in such a way that angle ADE equals to 2x. So actually we have here triangle ABD that has two angles that are equal to each other. Angle ABD equals to angle ADB that equals to 2x. So because of the fact that triangle ABD equals two angles that are equal to each other, therefore triangle ABD is an isosceles triangle. That is to say, AB equals to AD equals to 8 units, because we know that AB equals to 8 units because it is given us in the question. Because of the fact that those two angles are equal to each other in a triangle that is an isosceles triangle, we have two sides that are equal to each other. That is to say, AB equals to AD equals to 8 units. Okay, then we have a rule that if in any triangle, for example triangle ABC, alpha plus beta equals to the exterior angle, that is angle ACL. Again, alpha plus beta equals to angle ACL, that also equals to alpha plus beta. So we can implement this rule in our triangle, triangle ABC, because in triangle ACD we have angle DAC and angle X. So angle DAC plus angle X must be equal to this angle, that is actually 2x. Again, according to the rule that I mentioned, angle DAC plus X must be equal to the exterior angle, that is 2x. Again, angle DAC plus angle X must be equal to angle ADB, that actually equals to 2x. Okay, angle DAC plus X must be equal to the exterior angle that equals to 2x. The exterior angle ADB, that equals to 2x. So from this equality we can subtract x and we will find out that angle DAC equals to x. So this angle DAC equals to x. So we actually, in triangle ACD, we have two angles that are equal to each other, both of them equals to x. So therefore triangle ADC is an isosceles triangle. That is to say, AD equals to DC equals to 8 units, because we know that AD equals to 8 units. So DC that equals to AD must be also equals to 8 units. Okay, then we have another rule that states that whenever you have isosceles triangle and you draw perpendicular from point A, then that perpendicular creates two equal sides. That is to say, BE equals to EC. BE equals to EC. Okay? We know that triangle ABC is a isosceles triangle. That is to say, AB equals to AC. So if you draw a perpendicular to an isosceles triangle, then BE must be equal to EC. Okay? So actually, in the isosceles triangle ABD, we draw a perpendicular to BC, and therefore, according to the rule that I mentioned, BE must be equal to ED, and BE must be equal to ED according to the rule that I mentioned, because of the fact that triangle ABD is an isosceles triangle. Therefore, whenever you draw a perpendicular in an isosceles triangle, you create two equal sides, that is to say BE equals to ED, or in the point of the contact point between the perpendicular to the sides that you draw the perpendicular, BE must be equal to ED. Okay, so if we define BE as A, then ED must be also equal to A. Okay, so actually in the right triangle ABE, this is a right triangle because this angle equals to 90 degrees. We can implement the Pythagorean theorem in the right triangle ABE. We can say that AB square, the square of the hypotenuse, equals to BE square plus AE square. Okay, AB square equals to BE square plus AE square. And AB equals to 8 units, so AB square is 8 square, that equals to 64. BE equals to A, and we defined AE as H. So we got that 64 equals to A square plus H square, and we subtracted A square from this equation, and we got that H square equals to 64 minus A square. Okay, so we have another right triangle. This angle is a right angle. Therefore, triangle AEC is a right triangle. And in the right triangle AEC, we can implement the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to AE square plus EC square, and AC equals to 14, so AC square is 14 square. AE equals to H, so AE square equals to H square, and EC equals to A plus 8, so EC square equals to A plus 8 square. Okay, so in total, in triangle AEC, the right triangle AEC, the implementation of the Pythagorean theorem means that 14 square equals to A square plus A plus 8 square. Here we open the brackets, and we have here 8 square, but we have already found out, this is equation number 2, and from equation number 1 we know that 8 square equals to 64 minus A square, so we can substitute 8 square from equation number 2 by 64 minus A square from equation number 1. And the only variable that we have here is A, so it is one equation with one variable. We solve this equation number 2, and we found out that the value of A is 4.25 units. Okay, we found out the value of A, and after we know that A equals to 4.25 units, we have equation number 1 that states that A square equals to 64 minus A square, but we have already found out that A equals to 4.25 units, so we can substitute A square by 4.25 square, and we found out that H equals to 6.78 units. Okay, and so we know that A equals to 4.25 units and H that is the height of triangle ABC, equals to 6.78 units. So the area of triangle ABC equals to the base of the triangle times the height of the triangle, the height to the base, over 2. The height creates 90 degrees with the base. So AE is the height of triangle ABC when the base is BC. So the area of triangle ABC equals to BC times the height AE over 2. Okay? Again, the area of any triangle equals to the base of the triangle times the height over 2. So the area of triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is H, over 2. What is the value of BC? BC equals to A plus 8, or BC equals to 2A plus 8, and AE equals to H, and we have already found out that H equals to 6.78 units, and A equals to 4.25 units. So 2 times 4.25 is 8.5. So the area of triangle ABC equals to 8.5 plus 8 times 6.78 over 2. Okay, so we found out that the area of triangle ABC, according to the first method, equals to 55.935 square units. Okay, that is according to the first method, and we also found out the area of triangle ABC according to the second method. According to the second method, we know that the sum of the angles in any triangle equals to 180 degrees, and especially in triangle ABC, the sum of its angles equals to 180 degrees. So angle A plus angle 2x plus angle x must be equal to 180 degrees. Again, angle A plus angle x plus angle 2x must be equal to 180 degrees. Angle A plus angle 2x plus angle x must be equal to 180 degrees. Or A plus x plus 2x is 3x, so A plus 4x equals to 180 degrees. So we subtract 3x from this equality, and we got that the value of A, angle A, equals to 180 degrees minus 3x. Okay, angle A equals to 180 degrees minus 3x. Okay, and we actually have a rule. We have a rule about the area of a triangle. In any triangle, for example, triangle ABC, if the size of AB is A units and the size of AC is B units, and the angle between AB and AC is theta, then the area of this triangle, triangle ABC, equals to A times B times sinus theta over 2. Okay, so we can implement this rule in our triangle, triangle ABC, because we know that AB equals to 8 units, AC equals to 14 units, and the angle between AB and AC equals to 180 degrees minus 3x. So the area of triangle ABC, according to the rule that I mentioned, equals to AB times AC times sinus 180 degrees minus 3x over 2. And AB equals to 8 units, AC equals to 14 units, and times sinus 180 degrees minus 3x. All over 2, divided by 2. And we know that sinus 180 degrees minus theta equals to sinus theta, so sinus of 180 degrees minus 3x equals to sinus 3x. Okay? So we again sinus 180 degrees minus 3x equals to sinus 3x, and we have the following trigonometric identity that states that the value of sinus 3x is 3 sinus x minus 4 times sinus x to the third. Okay, and here we can take a common factor. So the area of triangle ABC equals to 56 times 3 times sinus x minus 4 times sinus x to the power of 3. Here we took sinus x as a common factor of this expression. We took out sinus x out of this expression, and we got it inside the brackets 3, and here we took sinus x as a common factor, so what is left here is sinus x squared. Okay, and then we use the law of sines in any triangle. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. And in our triangle we have the implementation of the law of sines means that 14 over sinus 2x equals to 8 over sinus x, or 8 over sinus x equals to 14 over sinus 2x, and we know that sinus 2x equals to 2 sinus x cosinus x, and here we can cancel sinus x because we have sinus x in the denominator of this side of the equation, and we have sinus x in the denominator of the other side of the equation, so we can cancel sinus x. And after we cancel sinus x, what is left is 8 equals to 7 over cosinus x, because 14 times 2 is 7. From this equality we got that cosinus x equals to 7 over 8, and we know that sinus, we have the following trigonometric identity that states that sinus x squared plus cosinus x squared equals to 1. So sinus x squared equals to 1 minus cosinus x squared. Here we take a root, we can take a root out of this equality, and we got that sinus x equals to the root of 1 minus cosinus x squared. And we know that cosinus x equals to 7 over 8, so cosinus x squared will be equal to 49 over 64, because we squared this equality and we got that cosinus x squared equals to 49 over 64. After we know the value of cosinus x, we can substitute cosinus x squared by 49 over 64 because it is equals to cosinus x squared. Okay, and so we got that sinus x equals to 1 minus cosinus x squared. We know that cosinus x squared equals to 49 over 64, so we can substitute cosinus x by 49 over 64. So we substituted cosinus x by 49 over 64, and we got this equality that states that sinus x equals to root 15 over 8, and so the area of triangle ABC equals to 56 times sinus x times 3 minus sinus x squared and we know that sinus x equals to root 15 over 8. So if we square this equality, we will get that sinus x squared equals to 15 over 64. So the area of triangle ABC equals to 56 times sinus x. Sinus x equals to root 15 over 8, so we can substitute sinus x here by root 15 over 8. We've substituted sinus x by root 15 over 8, and inside the brackets we have 3 minus 4 times sinus x squared, and we know that sinus x squared equals to 15 over 64. It is 4 times sinus x squared, that equals to 15 over 64. So we solve this simple inequality, and we grant that the area of triangle ABC equals to the root 15 times 231 over 16 square units. Again, the area of triangle ABC, this triangle ABC, equals to root 15 times 231 over 16 square units. Okay, thank you very much.